All right, hello and welcome back. My hair is drier than in the last video. It's still the Sunday I'm recording, and the sun is still out, so days are good. Uh, Plan today. It's data representation number 4. Plan be about the same as every other plan. I'm going to take a look at data representation 3 homework. A couple problems I found interesting, and then let's see what we're doing. Momentum, mass times speed, as I mentioned last time. Where is P? I'll show you where P was. Then we'll get into data representation practice number 4. We'll talk about some Punnett squares. It is one bit of biology that does show up with some frequency on the ACT science section, so you better know how to make a Punnett square and like talk about probabilities ranging from a quarter to 3/4 or maybe 0 to 1. Skip passage number 2, the second passage in the practice that talks about like a ball bouncing on a spring. It's real similar to a problem you did in homework number 3. So I'm just going to say skip it. If you'd like more practice, it's there. The key has the solutions. I'm just going to not talk through it for the sake of making this lecture video about 25 minutes long. And then the third passage has some weird looking graphs that are just awful to look at. And we'll talk through those. So, and then we'll get some homework questions. I've got 4 questions specifically I'd like to look at. You'll notice your homework, 12 questions of homework today. So guys, again, I'm going to walk you through 2 of the passages. You're going to have 2 to do on your own. Of this very important data rep stuff. And you've got a third one you can do if you'd like some extra practice. I'll answer questions about it when you're in here in person, but let's try and save it from the Zoom meeting. So, yeah, you can use the Zoom meeting, whatever. So let's get into it. We are doing data representation practice number 4. Check that. 2 questions I wanted to look at first. First being number 5 here, dealing with greatest amount of momentum. If you did not know about what momentum was, you couldn't answer that question. Where did the greatest amount of momentum occur? Momentum occurs when the speed is the greatest. When was the speed the greatest? 2, 4, 6, 8. There you go. Whatever. And then the other question of particular interest to me was, where is P? At time 7, the bottom of the cart is approximately how far above or below the point P? And you had to say, where the heck is point P? Point P is where the cart starts. How far has it fallen? At time equals 7 seconds, you take T equals 7, you take that up, you say that's right about here. How far has that fallen? Well, it's at 40. It was at where it started at 50, so it has fallen 10. A lot of people think P is on the card. A lot of people think P is at the bottom. People just get confused about what P is. So that was from homework number 3. Now let's take a look, like I said, at practice number 4 and then homework number 4. All right, so once again, I am just as straightforward as I can be with these naming conventions and these documents. This is practice number 4 and group work number 4. And again, I'll say it like a third time. Skip the middle passage in the practice. So tomorrow or the next day will be a I believe for at least for first block, we'll be taking it, or not first block, for the first group, we'll be taking a test tomorrow. So be ready. Remember, we've got a virtual practice test tomorrow. So we're on practice number 4 here, data representation. I'm always going to, pull a staple because I like to look at both these pages at once. Try not to step on that staple later. So we are talking about some fruit fly genes involved in sleep regulation. Doesn't that sound like a grand old time? So let's jump right into it. Again, you don't have to read any of this. You're looking at this and saying, oh, I know this is data rep because it's just a bunch of graphs. That's what data rep looks like. So let's start with pink today. So number 1, according to figures 2 and 3. So got a couple places mentioned. The fruit flies with a genotype associated with the least amount of recovery sleep per day had a maximum lifespan. Okay, so figures 2 and 3 suggest I'm going to combine some stuff. Figures 2 and 3. Okay. Least amount of recovery sleep. All right. Amount of recovery sleep. Here's the least on minus minus. What was the maximum lifespan for the minus minuses? The maximum lifespan seems to be right about 60 days. Boom. Easy peasy. Number 2, according to figure 2. Changing colors. Staying with me. The amount of recovery sleep for the plus genotype, recovery sleep, was how many times as great as for the plus minus? So let's consider for the plus compared to the plus minus. Recovery sleep, let's look at those two. Recovery sleep for the pluses was about 110. Recovery sleep for the minuses looks to be about 10. Well, those are about, so we're saying, how does 110 compared to 10? Well, it's about 10 times as great. How do I get from this to that? I might really multiply by 11, but 11 isn't an option, so I pick 10. Number 3, based on figures 1 and 3, once again, we have 2 passages mentioned. Excuse me, not passages, but figures suggest that we may need to combine some information. Of the flies that had an average of 12 sleep events per day, the percent that reached 35 days of age was closest to the following. Okay, so let's first find 12 sleep events per day. And you go over here and you say number of sleep events, and we see 12 is right here, so we're talking about the minuses. Okay, and then we see how many of the minuses lived to 35. So again, minus, I'm looking at the blocks. 35 is right about here. I take that up to that, and I take that over to the y-axis, and I see an answer very near 25%. Answer there will be C. 3 down, 2 to go. Let's go to green. Number 4, according to figure 1. Putting a box around figure 1, the amount of sleep per day for the minus genotype was approximately what percent sleep per day of the plus? So S minus, what percent of the S pluses? Okay, and it's sleep per day on figure 1. So we go back over here, figure 1, and we say sleep per day, pluses, that looks about 900. Minuses, that looks to be, okay, well, if 200 is here and there's a tick in between it, that must be about 100. So what percent of 100 is 900? 1 out of 9, what's that closest to? It's closest to 10%. So 100 divided by 900 times 100%, that would, you don't get a calculator, it's really 11%, but that's pretty darn close to 10. And the last one, suppose that a fly with the plus is crossed with a fly with the minus, resulting in 80 offspring. So a plus gets together with a minus, they got 80 little babies. Based on figure 3, the number of these offspring still alive at 50 days of age will be closest to the following. Okay. Well, what happens if a plus gets together with a minus? They're all plus minuses, so they got plus minus babies. So we need to say at 50 days of age, okay, well, let's go look. 50 days of age, it's right here. Plus minuses, that's the triangles. You take it up to the triangle, you take it over, and you got a value about 75% survival. That's the trap. The trap is 75%. Oops. D is a trap. Because 75% of 80. This is like the hardest question, number 5, I think I ever come across, because you just see the 75 and you circle it. but it's 75% of 80, 3/4 of 80. Well, what's a quarter of 80? A quarter of 80 is 20. 3/4 would be 60. Ooh. So the real answer there is 60. 75 is your trap answer. That's what you get if you don't read the question too clearly, because what is it asking for? The number. It did not ask for the percent. Common mistake. I love that question, number 5, because you have to be paying attention to those finicky little details. Gosh darn it. So A, J, C, F, C, where D was the trap. Look at questions like that. The number. The question asked about the number. The graph gives the percent. You got to look careful. That is a tricky number 5 question. Second passage has got a ball bouncing on a spring. It is darn near the same question as something we'd seen previous. I'm going to skip it. And then we're going to look at this thing dealing with the dang tropopause. And you say, what the hell is a tropopause, Mr. Kraviec? You don't know it. You don't care. Have you noticed? You don't have to understand these passages to get questions right. Look at questions 11 and 12. I see questions 11, 12, and 13, and I say, hot diggity dog, those look easy. Why? Because there's numbers for answers. Guys, if you have numbers for answers, that's good days for you, because that means it's on a graph somewhere. Probably, because that's where the numbers come from, graphs. 14 and 15, those got like, oh, so wordy. We'll talk about inverse and direct here on 14 in a moment. But 11, 12, and 13 are pretty darn straightforward. So you've got a 5 question passage. Stop. Give yourself a 5-minute timer. Do these 5. Pause it. Then come back to me in a moment. Thank you for pausing. If you aren't pausing, what are you doing? All right, so number 11, let's go ahead and get started according to figure 1. At 45 degrees north latitude, the air temperature at Earth's surface is closest to the which of the following? Okay, well, where's the surface? Okay, figure 1. 45 is the solid line, you'll notice. Where's the surface? The surface is 0. So where is that surface? That's value right there. That looks to be about 12. About as easy a question as you're going to see there. Answer C. Seriously, first question to passage should be freaking easy. Hey, go put your finger on it. Let's keep it rolling. I'll put that later in the rotation. Number 12, according to figure 1, the air temperature at 0 latitude is the same as the air temperature at 45 latitude at 45 north latitude at an altitude which is the following. So what does the same as look like on a graph? What does the same as look like on a graph? It is a place where they cross. It is a place where they intersect. We are looking for an intersection. If we are ever talking about the same as on a graph, it means that they cross there. So really we're asking, when do the 0 and 45 lines cross? The 0 and 45, here's 0 long dashes. Here's 45 solid. Where do they cross? They cross right here about 1, 3, 13 kilometers. Answer option G. Please make a note, intersections is what it looks like if they are the same. Number 13, based on figure 1, the average tropopause altitude for 30 north would most likely be, again, that most likely indicates that I need to estimate. So I don't have 30. If you look over on this graph, you see you don't have 30. You have 0 right here, and you have 45 right here. So 0 is at 17 and 45 is at 11. So where would 30 be? You would presume that 30 would be somewhere in between 0 and 45, given that 30 is between 0 and 45. So I'm going to choose the 2 values I know. It's got to be between 17 and 11. That's answer option C. First 3, good gosh, I think those are pretty freaking easy. Next three a little more difficult, and I'm going to take a moment to talk about inverse and direct. So let's make a little, everybody needs to make a little table down at the bottom for inverse and direct. I don't take a lot of notes, but we're going to take some notes right now. So what does that look like with an equation? What does that look like in symbols? What does it look like in words? Or yeah, let's just say, what does it look like on a graph? So in an equation, inverse looks like y equals, k times 1 over x. Direct looks like y equals k times x. That probably doesn't help you very much. Symbols, inverse, as x goes up, y goes down. As x goes down, y goes up. Inverse means they often go in opposite directions. Direct will often mean they go in the same direction. Direct here will be as x goes up, y goes up, and as x goes down, y goes down. So we're talking about direct, opposite and same directions. Graphs, what do those look like? X and y, that would be something like this. Graph for direct, something like that. So take a moment to ensure that you have that. In words, I guess I could put words down at the bottom. Inverse, they go opposite. Direct, they go same. Make sure you have that. That's not, we don't take a lot of notes in here, but that is one of those concepts you need to know. So let's answer it. Based on figure 2, was the average tropopause air pressure inversely or directly related to average tropopause altitude? Okay. Pressure related to altitude. Okay, figure 2. Let's look at figure 2. Here's figure 2 right here. Down here at the bottom. Here is pressure. Here is altitude. And take a look at those. Are they doing the same thing or the opposite thing? As one goes up, the other goes down. As one goes down, the other goes up. So you'll notice they're doing opposite things. So the very first thing you should do is you can cross out the directly options. It is not H or J. You know it is going to be inverse. What does inverse look like? Opposite directions. God, there's a lot of words here. It's either decreased, decreased, increased, increased, or decreased, increased, increased, decreased. Well, hopefully you notice that G is the only one of those that talks about opposite things. F sounds like a description of direct. There's a lot of words there. You got to see what the differences are. That's one you might ask me about in class. One left. According to figure 1. At 0 degrees latitude, how does the air temperature in the troposphere, so how does the temperature change with increasing altitude? Okay, so what does it do in the troposphere? What does it do in the stratosphere? If you didn't know what troposphere and stratosphere are, troposphere is at the surface, stratosphere is above the troposphere. So here's the tropo down low, strato up high. And what does it do for 0? Well, let's take a look at 0. At the beginning, in the tropopause, it's going down. And the stratosphere, it's going up. Tropo down, strato up. Tropo down, strato up. That's a hard one. Those first 3 were easy. Those first 3 shouldn't take you a minute apiece. Those last 2, you got to probably poke a little bit. That last one's hard. There's a lot of words there. Okie dokie. Let's look at that one, or those couple homework problems you have from group work number 4. A few things I want to make special note of. First one, talking about number 6. It's a hard question. The hint I'll give you. Who gets there first? Write that down. Might help you out. Next one. On a graph, what does something look like if they are very similar in thickness? Maybe that's something, thickness. Number 17, it asks you to do a number at 14,000, and you might see that the graph stops at 13,000. Keep that baby going. And number 19, it's talking about weight. And it says you need to look at the graph and what matters about weight. I will suggest to you that the distinction you need to make is between the gravitational field or density. One of those is going to affect the weight. One of those is not. Good deal. That's your assignment for today. Practice number 4, group work number 4. Tomorrow, at least in the first run through this, you'll be taking a practice exam at home.